Hello. Welcome. Thank you so much for coming. I think this is our 7th or 8th meetup. Thanks so much for N26 for hosting. Of course, Bruno's downstairs still bringing people in, but I think it's been such a nice office, and I hope everyone feels welcome. The bathrooms are at the back, next to the elevators on the right or on the left if you need them. Yeah, we have two amazing talks today, and thank you so much for joining. I know I'm super glad it didn't rain today, but yeah. There are open positions at N26 if you want to check them out. You can go to their careers website, or you can talk to Bruno after the break. Finally, I don't know if you noticed how hard it was to get in, but security asked everyone to give their first name, their last name, and it was such a hassle trying to reach you guys. So please join our Discord channel so we can chat and I can send you live updates about the next events. And thankfully, in the future, we can pass like these security bridges much more easier. So if you can please take a picture or join directly, there's the link. Thank you. I already sent an email. I'm going to send another one, and I posted on LinkedIn. Hello. Speaking about LinkedIn, of course, please follow us and share some love. We want to grow the community. We want to make sure that people continue to attend these type of meetups. I don't want in any way for the community or the meetup to die, so please spread the joy. We have some React dev certificates. If you are looking for a certificate, we have this company that gives a discount. One of our friends actually built the certificate, Aurora. She's a wonderful person, so check it out. And some React content, if you're curious, as if it's your first time here, this is basically made by me. So if you're interested, again, give me a shout out. We're going to start with our first talk. We're going to discuss about memory leaks. Here you go.
Or shall I try? Fair. My bad. Hi, everyone. Is that okay? Awesome. Okay, so yeah, thanks, Dan, for the introduction. I'm just going to talk a bit about the experience that we went through at Steam Local, and it's basically around memory leaks. Yeah. Fantastic. Thanks for the clicker, though. So just a little bit about myself. I've been a software engineer since 2017. I've been using React since 2019. And I remember because we used class components and there was no context. So it was pretty much of a hard time back then. And I'm currently working as the lead front-end engineer at Steam Local, and previously worked at Preply or Vista. Now it's Vista before it was called Vistaprint. Anyway, and about me, a bit different. I'm from the Basque country, so if anyone is interested in hearing this talk in Basque, please raise your hand. Nothing. Okay. A little bit outside of work, I play paddle, so if you find me on Playtomic, feel free to raise a match. And as a good Basque, I would say we always have the cooking in our veins. So I'm not a professional, but I like to, I don't know, invent some stuff at home. And the last one, I don't know, I wanted to have 4 circles. So the 4th one is swimming. Okay, so I'm going to try to explain a bit this in a storytelling way. Hopefully it's not too long because I forgot to put my timer. So if anyone can remind me when it's 10, 15 minutes, it will be fine. Thank you. So how it all started? Well, you know the spoilers about memory leaks, but let's just pretend we didn't read that. So you just get a very unsuspicious message, right? Very harmless message one morning, and the dates are important. I mean, I put some effort to put them there. And just as someone says, oh, is this page not working when I see some errors, or is this site down? You know, this very unsuspicious message. You just, as a developer, go there, check the website is working. You say, maybe it's just some fluke on the system, or, well, you just hush it out and say, well, I'm going to use the trump card, which is, it works on my computer. And you just continue. Not really. A couple hours later, the same colleague comes and says, well, we're getting really bad reports that pages are not working, or they're really slow, or we are not able to log in, etc. An array of errors. So you start, okay, I tried this in the morning. Hopefully it's still the same fluke, but then oops, you just get a very nasty error on your site. Okay, you say, okay, I'm able to sort of reproduce it, so I can dive in. So you just switch your hat from just trying to assist someone, and you just get your detective hat. And then you just go, the first thing is you just go to the monitors, and you see that for the day, which is the 28th, at the very end, you see that there is an abnormal spike on some errors. And you say, okay, that's not good. So you keep on investigating further into your infrastructure, and then you find that this is how your CPU usage looks like. Yeah. So that is what we saw, and the 28th is just at the very end. So this look is for the whole month, meaning that there are a lot of spikes in the CPU. Okay, that's also not a good sign at all. And then just right beside this graph, there's another one that is the memory usage, and then you go, whoopity. So there's really something going on. Okay, once you start discovering this, you say, oh, there is something at least positive, that the memory sort of resets from time to time. And the only thing that you can do is compare it with releases. So at least there's a way that you can mitigate the impact, but just simply correlating, right? You can see the April 22nd is more or less when you have one dip, the 16th, and so on. Okay, so this is pretty much where the fun starts. We sat down after raising the biggest alarm in the company. And by the way, I have to say that we are only 5 engineers, so it wasn't very difficult to gather everyone. And we just started blurting out the things that we found out. So the first thing is we saw that the errors on the first graph were just not very constant. So sometimes we had more errors, some other days we had less errors. So we just thought, okay, it's not very constant, it's not very deterministic, right? So that's the first thing. We have a spike on errors, and we need to identify why. Then, as I mentioned, we were able to correlate some of the dips with the releases. So that's also some breathing room for us in case we wanted to continue, because we need to keep serving our site. Then something that we assumed is that the error rate that we saw on the 500s was actually correlating with the memory increase, just because the more the memory increased, the more errors we were getting. And well, it was some hint that there was something going on with those errors. And then the last thing, which was very surprising, is that you could see back here that the memory only grows. It doesn't really go down without any action. So those are the things that we found while being in this crisis mode. So in the same meeting, we just sat down and we just thought, what could we do to try to identify the issue and also fix it? Well, the first thing is there was no information about the error through the logs. So we said, okay, let's just inject a bit more power into the logs just to try to understand how a request is traced through all of our services and see where maybe the faulty part might be. Since we have some CPU overload and also a memory usage increase, we were trying to add some tiny bit of caching to avoid extra computation, or also trying to already calculate some data that we needed for the front end. So we would avoid trying to consume memory. And we would also try to optimize the front end by lazy loading or trying to defer the content that is not visible on the viewport originally. So some optimizations. And then we thought, okay, so perhaps the problem is on the content, right? That we have so much content that we are sharing across different pages. Why don't we try to just trim it down in a way that we are showing some reduced content in one side, and we don't duplicate, for example, the FAQs on 7 pages, just to try to, I don't know, minimize the size that we're sending to the browser. And then something easy that we could see is just to scale horizontally, just add more machines to have more memory because we were running out of it. And then the last one about upgrading packages, well, we did a bit of research and we saw that there were some issues with the internationalization packages, that they were running out of memory, or that there was some pretty article that they said that they had some issues with a remix, which is the full stack full stack framework that we were using for our application. So this was basically the quick research that we did, and we got to it. We started working on it, and this is a bit of the release cycle, right? We don't do continuous deployment. We code freeze and we release every 2 weeks, one approach. And so we delivered the logs, but of course the logs by themselves are not going to tell us much. So we still saw the memory increase. We delivered the cache within the full stack application by adding cache control. And also we added a tiny cache between our application and the CMS, which hopefully sped up things, but it didn't really work. Then we got a bit dirty with the packages, such as the internationalization upgrade and the optimizations that I mentioned earlier, such as lazy loading or trying to code split our bundle. And then, well, something fun. We upgraded from Remix to ReactJS 7. And you can maybe see that there's a slight dip in the curve, right? It's not so steep, but we cannot really know if upgrading to ReactJS 7 was the I don't know, sum of the factor. We think that it was the horizontal scaling. By having more memory, it would grow. It will fill it up slower. And one thing I want to mention is that you can see that the 60% mark was sort of our top threshold in which we would reset our instances. But then we were getting some complaints already from customers that they were already getting slow responses. And we decided to just reset it more frequently. That's why you can see the dips, let's say, shorter in time. And this is, well, I showed you before that we were in the last of April. Now this is sort of the graph for the whole of May and a little bit of June. Well, yeah, pretty sad month. Okay, so once we were just delivering all this and we couldn't see any result, we just said, okay, let's just not run like headless chickens and think about this for a second. So we went through some LLMs and we just said the basic thing that we thought that was happening. And then one of the key words were memory leak there. So we brought back the article that we saw before, and they were also referring to some memory leaks. So myself, I've never done with one memory leak. I've heard of the concept. I kind of understood what it was, but never dealt with it. So it required more research. So we kept on doing more research about how to deal with them, how to read memory snapshots from either the browser or our server, some more in-depth research. And then finally, when you see that also Kent had some issues with memory leaks, you feel a bit better. Anyway, this is a really cool article in which you can see how they try to navigate some memory leak that Kent had in his own blog. It's a quite cool one, and that gave us a little bit of insights. Okay, so what is a memory leak? That's what we asked ourselves. So in short, I'm going to try to read through it. It's just when a program mismanages data that is stored in memory, failing to actually remove it from there, it just keeps it locked up. But if I were to try to summarize it, it will look like this. I'll just give you a moment. So, well, that's pretty much the summary of it. You think a memory leak is something that the memory is lost, but it's actually maintained within the operating system there. Okay, so that was the what, but what about how it happens? Well, firstly, your program needs to request some allocation of memory within the system that it's working on, and then it needs to just drop the data. Once it's dropped there, you just have it by reference. Could be a pointer, could be a couple of number of explanations. You can have a reference to the memory or just, well, yeah, pointer. Then something happens in your app, right? That either you lose the reference to the memory, but the memory is still there. So you cannot access it anymore. You cannot clean it. Could be that you have, for example, some event listener, and then you just place the callback there into the memory, but then you just don't clean it up. So it's still staying there. And then by not cleaning up the memory, then it happens that the memory keeps on increasing, and then you just have less and less memory. Eventually, it will just end up exploding the whole site. Okay, so this is a little bit of the demo in pictures of how we found where the memory leak was for us. First, pretty simple. You just need to build your full stack application. In our case was a React router. And once you just build it, you need to just serve it. Once it's served, you can just go to, we use Google. I think it's the best tool there for this kind of analysis. And once you just finish it, you just need to attach yourself to the inspector. Okay. Now you're going to have a nice window in which you can see that you are already attached to it. Be careful that if it's paused, then the server is not really running. So you just start it, and you already have eyes into what's going to happen behind the server. Well, the server part of the full stack application. Then it's just simple. We went through all the different flows that we had in our sites. Just, I don't know, the regular critical flow, just going from the landing page. We find different products. We check out one. We go to the order confirmation. That's pretty much one flow. But then we tried different flows, going to the blogs, going to the catalog. I shouldn't say plan. Plan is internal. It's through the catalog and so on. I don't know, browse different pages through your site to try to reproduce the issue. And from time to time, do not forget to keep taking snapshots. Now, one thing we could get a bit hopeful about was that the snapshot size was increasing in size. So it meant that there was something that we could perhaps hopefully find through these snapshots. Okay, once you have them, then you are able to compare your snapshots. I'm just in here showing the last snapshot compared to the first one that says on the very top. Apologies. And that's pretty much how it looks behind the scenes for your backend. Well, in this case, it was React Router. Since our hypothesis was that the memory was increasing, it was not decreasing, we would try to find those constructors or those elements in which there was no memory freed. So this is how it started. That's pretty much what we found by finding, well, we were trying to just, filter through the delta, which is how much added, how much released it was. So we outlined several, how many are there? For around 9 elements. So you just go one by one. So the first one, that's where we ended up. So the first one is just the React representation of all the countries that we are offering in our site, which, by the way, I forgot to mention one thing. I'll leave it for later. Since we just simply sell eSIMs, so you don't have to pay the roaming bill, we just have how much? 209 elements, well, or countries that we offer the eSIMs. Okay, so we already can cross one out because that is not going to keep increasing. We're not going to be having more and more countries. And if we are, it means we already are doing something wrong. But that number was not increasing. Perfect. The next one, or the next 3 actually, were something that I've never seen before. This domain lookup, start time, performance versus timing. Just a quick word on that is the web API on performance that you can see when you go to the network tabs, but Node did already adopt it in their system. And it actually only provides richer information about the requests that are coming out of your Node application. So it's actually, well, the 3 of them. Okay, so we assume that Node is not going to be causing the memory leak. So we continue. Then we have all 4 of these that are session, path, and same side. This is the React router representation of the cookies. Then we have the class name and children. This is the server representation of the server and the components for our application. We're not going to be adding more and more components by just simply working on React. And then this ID, link, and text is a separate representation of the anchor tags that you have within our Remix or React Router. They just separate it differently so they can access them separately. And then this one also threw me a little bit back. The name on the callbacks is when you have some that you need to have a callback, they're also stored separately. So far, all of them haven't netted any light. They haven't given us any information about the potential memory leak. But then there's the last one. It had to be the last one. So this auth class, what is this auth class? We expanded it, and we saw that we are using, well, we knew, but the reference is to the installed AWS Amplify. So we are just simply using Cognito to handle all the authentication in our site and app. And we were looking at it saying, let me just go back. Why do we have 34 instances of just this authentication class name? That threw us off. We just started to look about it, and there was already a memory leak reported, thank goodness, which is pretty simple. You can see that on the top, they were trying to fix some context module for SSR, which is basically what we were doing. We were trying to authenticate on the server to get the customer information, well, all the typical flows. And happily, that's what solved the issue. We upgraded from version 5 to, I think it was version 6. It took us quite a while. You can see that it was by the end of June when we released, and finally, the memory leak, we could just mark it as done. Okay, what were the learnings about that? Once you have the time to really dig deep and you're not panicking because there's an alarm going on, it could be quite fun. It's only fun. Well, it's fun because you can mitigate the issue, right? You can reset the instances. If you couldn't do actually any temporary remediation or mitigation, then that's actually far worse. So the key learning for us was that identifying that way to mitigate it was key for us to be more calm and be more focused on trying to find the issue. Another one was that doesn't matter if we added richer logs into our system, it wouldn't tell us where we would have the memory leak, because simply the more memory you have, the less power your system will have to process any kind of request. And at some point, it will just simply time out and it will not tell you where the issue might be. Something that was quite interesting for us, since we do cadent releases, like every 2 weeks we release, we found out that if we had, for example, a continuous integration, a continuous delivery system, we might not be aware that we have a memory leak because we are resetting our instances every so often. So pay attention if you are releasing every day. maybe you don't really need to deal with a memory leak, but maybe as you keep growing on visitors, it's possible that you are going to hit that. And the last one, performance. When you think about performance, it's about how fast your application can be. Different metrics that we have for core web vitals, like LCP, or other metrics such as the layout content shift or other metrics. They're not only about that. Like if you have a very sick system or very sick backend, your performance is going to also be affected. Did I miss out on anything? Yeah, don't rush with literally any approach. Well, that's pretty much on us, because we could have just, taken a breather before jumping into conclusions of what we thought could actually be working. Right, the thing that I forgot, and the marketing team will kill me if I don't do this, it's because today I asked them to give me some promo code, actually. But it will be just the 5-second ad spot that I will take from here. There. So a SimLogo, as I said, and I forgot, sorry. A SimLogo, we are an e-commerce company that we sell eSIMs. So if you're planning on going abroad, or maybe you are going on some remote regions within any country that you might need some coverage, you can also check us out. And if you use the ReactJS code, then you get 10% off. Well, that's pretty much it. Let me just go to the very end about the questions, if there's any questions.
Hello, nice presentation. So most part of these problems came from server-side rendering, or also you have a lot of leaking in the client side?
A lot of what?
Leaking in the side
leaking
on the client
leaking.
side.
It was only happening on the back end. Whether if it's a bad decision using server-side rendering, that's something debatable, or even using AWS, that's also debatable.
Next question. It's related to this, because if it's going to server, do you try OpenTelemetry?
No.
Because most part of the OpenTelemetry already have auto instrumentation for most part of your code. That means if you are using any call for GraphQL, APIs, Express, blah, 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 there's a lot of tools. You will find with the spams and traces pretty quickly which part of your code was leaking.
Definitely. Okay, thank you.
Will reduce a lot your problems, because OpenTelemetry is came for help us in that position.
Cool. Thank you.
Anyone else?
Did you thought of something to try to prevent memory leak before releasing? If you thought of something about to try to prevent memory leaks before releasing, I don't know if there is some instrument or something that you
okay.
find.
The only thing that we thought was, once we knew about the issue, we could only try to mitigate the memory leak by just resetting the instances. So we had a rotation of people working, either engineers or infrastructure, and then every now and then we would just check the metrics and then reset the instances. We didn't do anything proactive because, as I mentioned, we are really low on the engineering count. So we created a plan, we stuck with it, and it was only when we stopped to think about what was going on that we actually found a way to fix it. But there was no other way to prevent the leak. I don't know if that answers the question. Yeah, well, thank you.
So I understand that the problem was caused by a library, right? You were using for the authentication. Was that the way you used the library which was wrong, or did the library just have a bug?
No, the library had a bug. The actual fix was adding one extra line in the package, just saying that if you already had created an instance, don't recreate it again. So it was sorry?
Singleton.
Yeah, fair enough. So yeah, we couldn't have misused the API of the package. It was just broken already inside.
Last one.
You told that your first steps was to update all packages, and the problem was in package. So the problem was solved on their side during your investigation, or?
Okay, you're talking about when I was referring to, damn, I have so many slides. This one, right? When I mentioned upgrade packages. We did a quick research because we thought that maybe those other 5 things could perhaps mitigate or reduce the leak in somehow. So we made a quick research on what are the top 2 packages that could be potentially causing leak. Although we didn't prove it, we found some evidence online that said, okay, it could be either the way that we're using Remix or React Router, or maybe it's about the I18N. And we were using those 2 packages. We said, okay, let's try first with those 2. And eventually was the 3rd one.
Thank you. Let's give him another hand. And now please welcome Katerina. She came all the way from Estonia to speak to us today. And she's going to talk to us today about animations in React. So thank you, Katerina.
Hello, everyone. I'm super excited to be here to talk to you all about animations. Are you excited to learn about animations? Let's get animated a little bit. Yeah. So as you know, in our web interfaces, most changes happen instantly. You click on a button and then boom, like a part of the UI just teleports onto the screen. But that's not how things work in the real world. The change usually involves motion. And our brains are wired to understand motion, as we've been seeing the physics of the real world around us our whole life. And this can make user interfaces feel a little bit mechanical and disconnected from how we naturally expect things to behave. And animation can help bridge that gap, and it can help to make our UIs feel a lot more tangible and real. And it can make really wonderful things for the user experience. For example, in the Apple Photos app, by the way, these are pictures from Buffered Read in Turkey. You see how when I tap on the image, it grows exactly from the place where I tapped, creating this connection between my action and the result. And as a result, I understand immediately what happens and how to get back. Another example is when you log in into Netflix user account, you see how the avatar smoothly animates into the toolbar. It does look nice, but it also communicates how can you change your user account after you've logged in. Or you probably use the calendar app. The simple sliding animation helps you to understand the actual direction you are moving on the timeline and gives you feedback about where you're going. And our brains are also wired to detect motion, and it means that animation can be a powerful tool to grab users' attention. Like in Figma, for example, when you try to discard a comment that you haven't finished, the comment box shakes a little bit to help you understand that, hey, maybe you want to do something here else. Or you can look how Airbnb uses animation to highlight important notes for the customers that otherwise could have been missed. Sometimes animation can also be useful to add a little bit of joy, whimsy, and delight into the UI. For example, these 3D animated icons in Airbnb. I sometimes just go into Airbnb and switch between them just to see the animation play out. It just looks so nice. What is character animation in Notion AI? These little things can seem small, but they create personal connection between the user and your product. And you want your users to feel joyful when they're using what you've built, right? And especially right now in the age of AI, where it becomes so much simpler to build simple looking UI, details like this can really create a difference and differentiate your product from the rest. We have CSS, we have some JavaScript APIs and the web APIs like view transitions, and a lot of libraries to help us animate things in the UI. And throughout this talk, I want to show you a lot of practical examples of how we can use all of these tools to add some meaningful motion into the UI. But first, let me introduce myself quickly. Hola, in Spanish, hi. My name is Katrina. I'm Ukrainian, but I live in Estonia for the last 7 years. And I work at Buffer, where I'm leading our front-end direction. And we've actually been focusing a lot more on delightful things like animation, which is why I'm really excited to talk about it. But we've got quite a lot of content to cover, so let's dive in. And I want to start with CSS animation. This is the most accessible tool for animation we have, and it sets the foundation for everything else we're going to cover. I imagine a lot of things that we'll be talking about are familiar for you, so I'll move a little bit faster. If you want me to slow down, you can just show, and I can slow down a little bit. But let's start. One of the simplest type of animation that we can do in CSS is transitions. So if you have a property that's changing, like opacity here, you can add a transition that will let the browser know to animate this change. Here we are saying transition our opacity property during the duration of 300 milliseconds. And this change, then the opacity on hover will be smoothly animated. The way it works is a browser takes this start value and end value and then calculates all the intermediate values in between needed to animate each frame at 60 frames per second. And that creates a smooth transition that you can see in the UI. This is also called tween animation because it calculates all of the in-between values to reach the final state. And in this way, we can animate a lot of CSS properties that can be interpolated. Things like width and height, padding, box shadow, and colors, we can animate using transitions. One of the most powerful things we can animate using transitions are transforms. And different CSS transforms are super powerful tool for the animation because they allow us to change how our element looks, scale, rotate, and skew it without affecting the document flow. So this is a very powerful tool for animation. So let's talk a little bit about how we can use transform to animate different states in the UI. By the way, we can now use separate individual properties in CSS instead of one transform property, which has been already well supported in the modern browsers for a few years, which I will be using throughout this talk. Let's start with translate. When we are translating an element, we can imagine it on the X and Y axis. If we change X value, it will move the element left or right. And if we change the Y value, it will move it up or down. The interesting thing about transforms is how they work with percentages. If we would provide a percentage value inside the transform, it will be working relative to the element's own size, which is a little bit unusual in CSS, as most of the percentage values work relative to the parent size. And this has actually enabled this old trick, if you remember, for centering elements in CSS. Basically, what we were doing is we were positioning the top left corner in the center of the parent and then offsetting by shifting the element back of half of its own dimensions to center it properly in CSS. This is where like a lot of the interview jokes on how to center a div came from, because this was hard to do. Right now we can of course have a lot more modern tools to do that. Now let's look at the example and implement a hover card like this. When I hover the card, it displays like a little panel with more information, which is really common way. So we can already have a little details panel is already absolutely positioned on our card. What we need to do is shift it out of the view so it's not visible. We can use this percentage trick by shifting it by 100% down. We can see that it shifts back on its own dimensions, but there's still a little piece that sticks out, so we need to account for margin as well. Now we need to make sure our users cannot see it, so we'll apply overflow hidden. And then, of course, when the card is hovered, we want to show this panel back. So we'll reset translate to 0 when the card is hovered. Now, the last thing that's left is to add animation. We can use transition to do this. We say that we want to transition translate property over the duration of 150 milliseconds. And now our panel animates. Looks nice. But of course, when we are implementing things like this, we need to not to forget about keyboard interaction. So in addition to hover, because this is an interactive element, we need to make sure we handle focus as well. So I'll add a focus visible here to make sure the animation will play out when I'm focusing too. Now, as we've talked about translate, let's quickly talk about how we can use other transform properties as well, like scale. It would scale elements relative to its own size. And one of the really common applications for it is to scale buttons slightly when they're clicked. And it actually creates a really nice feedback loop because you can see the button reacting on the click slightly by scaling down. So it responds to the interaction a lot more immediately if it wasn't there. Another really often overlooked part about transforms is the origin-aware transformation. We can use transform origin property in CSS to specify almost like a pivot point around which the transformation would happen. By default, it is in the center, but we can put it anywhere on the element itself or even outside the element to define how the transformation would happen, which will decide how it looks. A really common application for it is for things like drop-down menus and popovers. Ideally, we want to make sure that the interaction where we are triggering the popover really defines the direction of the animation. You can see the comparison here. So there's one that is defined on the top left with the button, and another one is on center. I think it's a little bit clearer to see when this slowed down. You can see the one that's defined with top left, it almost feels like the button spawns the drop-down element. So the interaction feels a lot more connected. The menu feels connected to where you triggered it in the button. It's especially visible when the elements are a lot bigger. Another important piece about transforms overall is the performance. I think they're especially useful for animation because they are very performant to animate in the browser. To understand why, let's look a little bit on how browser rendering happens. So typically, it starts with browser running your JavaScript, after which there's a step called style, where it figures out which CSS rules needs to apply to which elements. Then it needs to calculate all of the different size and positions of every element on the page, after which it will draw the actual pixels on the page so the user can see them. And then there's the last composite stage where it takes all of the painted layers and combines them. And depending on which stage the animation for specific property happens, it can have a different effect on performance. And generally, the further right you animate, the better it is for performance. And this is why animating transform and opacity is very powerful, because it can happen on the composite stage, meaning that the browser needs to do the least amount of work to animate these properties. And they can be handled by GPU. Animating things like background color, border color, and box shadow, everything that doesn't affect the layout of the page can happen at a paint layer, which is the next best thing. Typically, these animations are quite performant. But animating things like width and height, top left, padding, and margin can actually be quite detrimental to performance, because at every frame of the animation, browser needs to recalculate all positions for all of the different elements on the page. I don't want to scare you from animating width and height. I think modern browsers are quite performant and incredibly fast. So sometimes you genuinely need to animate width, height, and other properties, and that's totally okay. But knowing how that animation happens and how it affects the performance is helpful to then optimize it. Another important piece of the CSS animation that I wanted to cover that can really affect how animation feels and looks is timing and timing functions. So when we set a transition like that opacity that we did before, we can also provide a timing function, which will define how animation plays out. There are 5 timing functions that are supported by browser. They're built in. And ease is the default one that we've been using so far. Here is a good example where you can see different timing functions are compared. You can see how certain animations in these elements feel faster than others, right? But the duration for them is actually completely the same. I think it's even clearer to see when I slow it down. You can see how ease and ease out feel the fastest of the 4, and linear almost feels like really sluggish. Almost the interaction is too slow. And this is why choosing the right timing function is important. Here you can see all of these timing functions on a timeline. For example, linear moves at a constant speed, which is typically a little bit unusual. In real world, nothing moves at a constant speed. Ease starts fast and then slows down towards the end. Ease in is almost like vice versa. It starts slow and then speeds up. Ease out starts fast and then slows down. And ease in out combines both. It starts slow, then there's fast middle, and then there's a slow end. But additionally to all of these functions, we can actually define our own. We can define Bezier curves to define this curve by how our animation should play out. These curves are defined by 2 points. So there is an point 1 and point 2 coordinates that can define how the curve looks. I know it can look a little bit complicated, but luckily you don't really need to do that really often, because there are amazing people who have created a lot of pre-built timing functions that you can use for your animation. There's this website called easings.net that has an extended set of timing functions that you can just copy and paste. And there's also this really cool tool called Easing Wizard, where you can actually go and like play out, change the different functions and see how they affect the animation. This is a really nice one. One thing that I like to do is predefine certain timing functions, like the ones from the extended set that I showed, and save them as CSS variables, and then they're available for you to use for any animation you want. But now let's talk a little bit in which cases should you reach for which type of the timing function. Ease is a default for a good reason. I think it's a nice starting point for a lot of the animations. It typically starts faster, so it feels quite responsive. And it's good for any simple interactions like hover effects or small movements. Linear generally looks quite unnatural. So I think it's good mostly for things that need to move at constant speed, like maybe marquee element, a spinner, or maybe an animation for a skeleton loading. My favorite set is the ease out. Like a lot of these functions from ease out extended set, these are really nice for interaction because they all start really fast and then they slow down. So it feels like the animation is really responsive, which is what we want. We don't want the animation to get in the way of users interacting with our UI. Here's a comparison, for example, between ease and exaggerated ease out curve. You can see how ease out feels so much faster. It feels like this UI is a lot more responsive. Now, in addition to timing function, we can also define the duration of the animation. So I wanted to briefly talk about that as well. We generally don't want animations to get in the way of users. So I think choosing a really short duration, something up to 200 milliseconds for some smaller interactions like opening popovers or models or tooltips is really good. But sometimes you don't want to have any animation at all. So choosing maybe duration of 0, not setting animation for any keyboard actions, for example, or any interactions that happen very often so that users don't get annoyed with the animation. And then for some larger animations or maybe more aesthetic animations, choosing a higher duration can be really nice. But of course, it all goes hand in hand with the timing function that you choose, as we saw in the examples before. And now the last piece with the CSS animations that I wanted to cover is keyframes. And keyframes are quite powerful for a lot of types of animating elements on the screen because they let us create reusable animations with multiple different steps that we can apply to any element. Like, for example, here I'm creating a spin keyframe that just rotates the element 360 degrees. And I can apply it to spinner, but then I can use the same animation and apply it on a completely different element on hover interaction for this React logo, for example. We can also use keyframes. I think the big use case for them is to animate enter and exit of different elements. And a nice part is that we can create different keyframes, for example, and set them for opening and closing, like here. You might notice that I even chose different duration. So when element enters the screen, the duration is a little bit higher than when it exits the screen, so that it gets out of the user's way much faster when they want to finish the interaction. Now, remember that little comment box from Figma from the beginning? Let's see how we can implement something like this using keyframes. So we can create a keyframe to shake. So I'm just rotating the element a little bit and then moving it by a few pixels back and forth. And then we probably want to shake it a few times, right? So we can create a few of these. A nice thing about keyframes is that we can also actually just compact definitions by repeating them with commas like this. And then when the state is right, like here, when there is some unsaved data, we can just apply this keyframe. Doesn't that look nice? A little jiggle, it feels delightful. Another nice way to use keyframes is to stagger different effects. Like here, this is from Vercel's design system. You can see how once you submitted feedback, there's a little wave going on, like elements appear with a little delay. Let's see how implement something like this. We generally have 3 elements in here, right? We have a check mark, title, and text, and we can apply the same sliding animation to all of them. But then we almost want to stagger them so that each next one starts with a little delay. We can do it by applying animation delay property on the element, which will work, but you can see there's a little issue here, right? The check mark looks fine, but the title and text, it doesn't really animate properly. It almost flips instead of sliding down. This happens because when the animation kicks in, the element already exists on the screen with full opacity. And then it resets to opacity 0 from our keyframe. So we can use this animation property called animation fill mode, which is actually really cool and quite powerful, as it allows us to control which styles are applied to the element before and after the animation runs. And backwards is the one that we need that will apply all of the styles in the initial keyframe to our element. So just by adding it, we now have a really nice interaction. Doesn't that look nice? A little wave. And we've been adding already quite significant animations on the screen, right? We had this comment box that shake. We have this, like where elements move. So I think this is a good time to talk a little bit about accessibility of animations. Some people with vestibular disorders can have negative physical reactions to motion. So certain animations can make people feel dizzy or nauseous. Fortunately, a lot of devices and already support a way for people to set their motion preferences and reduce this motion. And CSS gives us a way to respect these preferences. And this is important to do, but first let's cover what kind of animations are problematic. Generally, the animations that can cause issues are larger movement, like maybe large-scale movement, some kind of parallax effects, spinning and continuous rotation of animation, some zoom and scaling, especially when it is very rapid, autoplaying videos and GIFs, or maybe really rapid back and forth motion. Generally, opacity changes and color changes are safe, so we can still use them. And there's even some research in terms of which amount of motion is still acceptable. So the way we can respect these preferences in CSS is by using media queries. There's a media query called prefers reduce motion, which supports reduce or no preference. So one way we could do it is we can just disable the animation when the preference is set. But I think even better would be to treat that as a default and just not set an animation unless the preference is not set, which is then animation sets is only when motion is okay. And here is the end result. You can see that when there's no preference, we still have this little pulsating motion. When reduced motion, it's completely static. And we generally don't have to remove animations entirely. Like in this drop-down example, we can just replace the animation with something that is a little bit more gentle. So instead of scaling, we can just use a normal fade in and fade out. And that's totally fine. We can just provide an alternative that doesn't include a lot of motion. Now with reduced motion, you can see this is without reduced motion. But then I go back and I apply reduced motion on here. And you can see now it just appears with a little gentle fade in and fade out. Now we've covered quite a lot already about CSS animation. We've talked about transitions and keyframes and also some of the modern features and accessibility. And I want to tell you about a really exciting web API that's already quite supported in modern web browsers and I think is ready for us to use, which is View Transitions. View Transitions is a web platform API that was pioneered by a Chrome team and is already quite well supported in modern browsers. It's supported in Chrome and Safari and is in the technical preview of Firefox. So it's coming to Firefox really soon. But the nice thing about View Transitions is that we can treat it as a progressive enhancement, meaning that in all the browsers, everything would still work. They just wouldn't get a nice animation. There was this really cool demo on how they work. You can see that it looks very native. And this is the kind of experience we can already create on the web. How cool is that? You can even notice that the video keeps playing when you transition to a different page. So let's see how we can use it. I have this little carousel that displays tips about view transitions. And right now it's a little bit boring, right? It just swaps instantly. And the nice thing about view transitions is that it's super easy to trigger them. We just need one additional line of CSS. We need to wrap our change, like going to the next tip, with document.startViewTransition in JavaScript. Of course, we need to make sure it still works for browsers that don't support it, so we need to add a fallback. And now you can see there's a gentle fade in and fade out, a crossfade happening with just this one line of JavaScript. This is the default animation that browser applies. Let's talk a little bit about how this works, because view transitions are a little bit interesting like that. So the way view transitions work is that when you trigger this view transitions in JavaScript, the browser pauses rendering of the page, so nothing is interactive. Then it takes the snapshot of the current state of the page, then executes your update, and then takes the next snapshot after the update. Then it overlays these two snapshots and animates between them. You can even see it happening in real time if you open DevTools. You can see this little pseudo element popping up in the DOM tree. These are the snapshots that browser is making for the view transitions. And the browser provides a default view transition for the whole root element of the document with this gentle crossfade happening. But we can actually customize it, which we will see later. In order to use view transitions in React, we're on React Meetup, right? We need to actually do a little bit of extra tinkering. Because React batches updates and executes them asynchronously, we just understood the browser needs this to work synchronously. So we need to tell React to execute this update asynchronously with flush sync. Then the change will be applied immediately. This code is already starting to look a little bit ugly. So we can just abstract it in some kind of hook or little function that we can just use in the future. Something like this. Now that we've already applied the function, I would love to talk about how we can customize this animation. Because crossfade is nice, but it would be really cool to create some kind of custom transitions. I have this little zoom in and zoom out effect. And the way we can do it is we need to tell the browser what kind of animation is happening. And we need to do it with view transition name property. We need to just apply it to the element that we want to animate differently. And then using those pseudo classes that I showed before, we can just change the animation and apply different keyframe instead. So you can see here right now, did you see there was like a little zoom effect in there? Yeah, like this. Right? So you see right now, just change a few lines in CSS and we have a completely different effect. We can make it even more fancy, add some movement with translates and transforms, and have this little flipping animation going on. And this is all really simple and it builds on everything that we just learned about CSS animations. But I think it's one of the least cool features about view transitions. So I want to talk about how we can animate elements between different views. I have this little video, like a YouTube clone kind of app. And you can see I have two pages. I have a list page where all of the different videos are shown. And then I have a details page where I display a video player. Right now, it just instantly switches. But notice that the thumbnail and the player are actually kind of the same. It would be really nice to animate it smoothly between these different views. And we can actually do it with view transitions. If we can use the same property as we used before with view transition name, the issue is that these names need to be unique. So we can just provide the view transition name with the specific ID of the video. And we need to provide it to both elements so that the browser knows that it needs to specifically morph between these different elements. So I add it here to the video preview. And then I can go to the video details page and apply the same style. Of course, we need not to forget to use our handy hook and just wrap all of these interactions with the start view transition function. And now, cool as that. That was very simple, right? You might even notice how even when I go back, the thumbnail smoothly animates back into its place. And this is all just done by the browser. We didn't need to do any work. I think this deserves an applause. Of course, animations like this, when there's a lot of movement happening, are not very accessible. So we need to make sure we still respect people's motion preferences. One way I would do it is I'll probably just disable all of the animations with custom view transition name, but you can do it on specific animations as well. The nice thing is that view transitions are also already quite supported in all of the different frameworks. We saw a demo from Astro from before, but they're also supported in React Router. You just need to add view transition prop onto your links, and then the React Router will kick in the view transition when you're changing your routes. So it can work multi-page as well, when you're going from one page to another. They are also quite nice for animating different lists. I think this is like a demo that looks really cool. So right now we have a little list with different people that we can delete, filter, search, etc. And it's really simple to apply view transition here. We just wrap all of these interactions with start transition. And then we just add on the same view transition name with elements ID. And that's it. You see how they smoothly move into the new place. I love that we've gotten into a habit of doing applause. And this is really simple. Of course, you probably don't want to apply this animation to all of your lists, but it can be nice in some specific places. And one more thing, React actually has experimental API for view transitions. So they will be supported at React level as well. And after support lands, it will be supported in Next.js as well. But now you can still use them in experimental mode. You can create custom ones just by hooking into CSS and JavaScript, but they will be supported officially. And it works on top of the same web API we just discussed. So the way it works is that React gives us a view transition component, and then we'll generate automatically these unique view transition names for elements. The only thing that we would need to make sure that we do is to tell React when view transition should happen. And by default, it will happen when update triggers as part of concurrent React transition. Like, for example, using the new React hook called use deferred value, or using a start transition hook, or if you use suspense when suspense boundary is resolved. With these changes, this is how our demo look with now using React. So this is experimental API, so I don't recommend using it in production. There's still some bugs they're resolving, but once it lands officially and is stable, it is much nicer as you don't need to create custom names for view transitions. But you can already use them with just what we showed before. So view transitions are really powerful for creating these native-like morphing animations in the UI. So we already covered CSS and view transitions, and these are very powerful tools, but they have something in common. they're tween-based. You remember that in-betweening, right? We define specific start and end point, and the browser interpolates between them. This was great for many things, and with a more realistic easing curve, I think we can quite adjust how the element moves. But bringing back to the connection to the real world, that's not how it works, right? If you pick up an apple and you drop it on the floor, you don't define how long it will take for apple to drop, right? It usually depends on the physics, on its weight, air resistance, the force you apply. And so the duration is a result of these physics and not something that you predetermine. And CSS is almost work backwards from that. So, which brings me to the last little bit that I wanted to cover, and it's spring-based motion. For example, if you have an iPhone, you might have noticed that animations on iOS feel so nice. They feel really responsive and alive. Everything has a little bit of weight and momentum, and they work based on spring physics, and we can use these on the web as well. The way springs actually work is that you can imagine an element you're trying to move attached by a spring that's pulling it towards its target position. And spring has some physical properties. It can be a little bit more stiff or less stiff, which will result in it pulling harder or less hard the element into the position. Element can have different mass, and environment can affect how it moves. And animation would be a result of all of these forces working together. I wouldn't be able to go in a lot of details in how, in the physics of using springs. So there's a really cool blog post from Josh Camille about spring physics that I really recommend to check out. And generally has a lot of really good resources about animation on his blog. When it comes to web and React, there are several libraries that allow us to use spring physics. One, and really famous one, is GSAP. We also have React Spring. And we have Framer Motion, which is now called just Motion. It's the same library from the same creator, just kind of rebranded. And this is the one that I want to focus on during this talk, because I think it's quite well supported and has really big community around it. It also has really cool docs, so I really recommend checking them out. There's a lot of really good examples of different types of animations that you can create. The way it works is it provides a motion element, and then you just need to replace elements with a motion version of them, which give them certain superpowers when it comes to animation. And so this API looks very intuitive and declarative, so it's very familiar to how we already write our JSX. So let's look a little bit on motion in animating this little toggle here. So I have toggle set up. So I just need to import motion, replace my span with motion.span, and then I need to tell it how to animate it. So I'll just tell it to move depending on the value of the toggle. And this X, it's completely the same translate that we used before. Motion will just apply it for us. And that's it. You see how it has a little bounce? So this toggle is already powered by springs. There's one little issue with it, is that if the initial value will be true, it will animate to that value. So we can battle it by just setting initial to false, which will then remove this animation. I think you can see advantages of motion by looking at the comparison. You can see how motion is really interruptible, right? You can click really quickly and will smoothly animate into the new position, whereas C doesn't really work so smoothly. But the real power of motion actually comes with layout animations. They automatically allow us to animate changes in size, position, or others without calculating anything manually. For example, we can build animated tabs like this. If you were to build it with JavaScript, and I don't know, have you tried to build tabs like this before? It is hard. I need to measure the width of each tab, calculate its position, animate that position and width, react to window resize, calculate everything on font size changes. There's a lot. There's even this video from Kevin Powell that's 30 minutes long. And he's like the master of CSS. So it would take even longer in reality. But with motion, it's super easy. We already have these tabs implemented with Radix, and we have absolutely positioned indicator here. So we, of course, need to change it to a motion element. But then we can just give it a unique layout ID. and motion will animate it automatically. So it works similarly to view transitions before. It will detect when the element changes and animate smoothly between its positions. Look at that. That was like 2 lines, and it works. You can see how animation feels a little bit differently depending on the distance that the elements need to travel. But there is a little issue right now with this animation. You see how like it looks a little bit weird when it's slowed down? You will see it right now even more so when I go back into the privacy and security. Look at that. That doesn't look nice. The way it happens is motion handles a lot of these things under the hood. And it works on all of those CSS transforms that we discussed before, which is why it's very performant. But at the same time, under the hood, it actually just scales the element, which can sometimes won't work well with proportions. So there's a lot of these little quirks, and border radius is a really famous one. So the result, the solution is quite simple. We just need to explicitly specify the border radius, and motion will help handle it automatically for us. And now it works really, really nice. Just look at that. Of course, we don't want our animation to run so slowly, but it does look very peaceful. Let's talk quickly about configuration options that we have available with motion. It provides us a transition prop. And with this transition prop, we can configure how Spring should behave. There's 2 main ways to configure motion. One is the simplified one, where we just provide a visual duration. This is not real duration. This is almost real duration. And this is by the time most of the animations should be complete. And then we define bounds, which defines how much overshoot you get. And of course, we have control to the full physics configuration with stiffness, damping, and mass. But it's a lot easier to see at the example. So here's our tabs from before. You can see I'm changing the visual duration, and it feels a little bit smoother, right? It feels really gentle. Now with bounds, you can see it overshoots a little bit more. You can see how we can create completely different feeling just by tweaking these 2 properties. If we go into the Spring physics section, then with stiffness, we can control how aggressive our spring is. You see that with the higher stiffness, it just moves the element faster. The damping controls almost like the environment, how quickly the spring stops oscillating. And then, of course, we can control the mass, and heavier objects would move slowly with that spring. I would recommend using the simplified, the visual duration configuration for a lot of the things because it's just more intuitive. But with Spring Physics configuration, we can really create, it has a lot of power and it's really configurable. Motion has this tool called Motion Studio, where you can play with a lot of these configurations yourself and then copy configuration into your UI. I think it takes a little bit of time to develop intuition on how to use these different properties. So I would just suggest to go by feeling and try different out and see how it feels. And over time, you will develop a good intuition when to use which property. Another thing with motion, as you've noticed, a lot of the animations that we use, they are quite taxing. There's a lot of movement. And this can be not very accessible. The good thing is that motion allows us to respect the user's preferences just by setting it in the motion config. If we set reduce motion to user, it will then automatically disable all of the animations that are based on transform or layout, but we'll still keep animating opacity and border color because these are okay. So you can see I just changed the setting and the animation was disabled. By using layout animations, we can create a lot of cool stuff like this. These look really nice. But also we can use them to animate CSS properties that are not animatable, like flex position or grid. So possibilities are really endless. But one specific opportunity to use motion that I really love is animating SVGs. For example, if you use Claude, you might have noticed there's like a little gentle movement when you go over different menu items, and it looks really nice. And something like this is super simple to create with motion. If you use icon library like Lucid, you can usually export SVGs, and they come broken down, so you can animate different parts of the SVG separately. And for example, we can create a simple drawing animation of our SVG with just animating the path length like this. And now with this animated, look how it looks. Isn't that nice? And this was very simple, right? We're just animating the full path length. We can create even more complicated ones with 2 elements where We can just animate them separately like this. But when they come at the same time, it looks a little bit odd. So we can add a little delay to make it better. That's nice, right? And we can animate a lot of interactions like this with just animating different paths. They support all of the normal things like animating opacity or duration. And we can create stuff like this. Ooh, ta-da. The nice thing is that you don't really need to do it from scratch. Motion has really good and prolific community. And there are really nice people in the community who have created already libraries of pre-made animated icons and a lot of other animated components, like this one, for example. Or there's a whole library called Animated UI with a lot of icons and other components already animated with motion. So we've covered already quite a bit, and I imagine you're a little bit tired. There was a lot of information. So let's recap a little bit. The CSS animations are a really nice default. They're already well supported, they're very performant, and they can handle majority of our needs. Animating simple hover effects, enter and exit animations, or any repeatable animations like spinners, like skeletons, etc. View transitions are really nice for like larger changes between routes or any spatial relationships. And with their support now at the React level and in the browsers, they're especially cool to start using already. Spring-based motion is really nice to add a little extra oomph, where we can use it to create more sophisticated animations that are very natural and interruptible with a cost of adding a little bit to our bundle size. Now, I hope you got a little bit inspired to animate things in your UIs and learn the thing of two. And thank you so much for having me here. And I think we don't have time for questions, so you can grab me during our food break to ask any questions. Thank you.